Hello. We are getting ready to do a science. We just checked our homework, checked the kinetic energy, getting ready to do potential energy. Pretty brief, pretty quick reading. Give them time. They will have time to work on their homework in class. You'll find that a lot of the questions on the potential energy are the same as the kinetic. The one thing you do want to remember is when you're doing the math on the back part of this homework assignment, the gravity is going to be 9.8. Okay, that's in the reading, but a lot of people kind of forgets that as when they get ready to do the math. Okay, so kind of keep that in mind there. It's very simple. Okay, and here we go. All right, let's talk about potential energy, Brady and Leo, because you both have such great potential. You're full of energy. You got potential. So it all plays in together. All right. You're going to see a lot of this is going to be a repeat. There's a lot of similarities between kinetic and potential. Okay. Not 100%, but a lot of very similar things are very similar to it. Okay. We talked about this a little bit about potential energy is the stored energy of an object that has let me start all over again because obviously it's Monday. Okay, potential energy is the stored energy an object has because of its position or state. Okay, so it depends on where it's at as to whether or not it has potential or kinetic energy. Okay, a bicycle sitting up on top of the hill has potential energy. If you hold a book up over your head, potential energy. If you stretch a spring really far out, it's got potential energy, okay? But it's not moving. Okay, all these things are kind of sitting still at this point in time. Okay? So it's got potential energy. The standard unit for measuring potential energy is the joule, which of course is abbreviated with the capital J, just like all the others. But how is it different from kinetic energy? Okay, potential energy is stored energy, while kinetic energy is motion. Okay, so if it's in motion, it is kinetic energy. If it has crest, like the roller coaster car we talked about, as it's cresting up at the top, it has the most potential energy at that time. But once it starts that downward motion, it's losing potential energy and gaining kinetic energy. Okay? So when potential energy is used, it is converted to kinetic energy. So you can think of potential energy as kinetic energy waiting to happen. Okay? So it shows you a picture there. You got a ball that is sitting up on a shelf perhaps. It has potential energy. Okay? But the one that is falling has kinetic energy because it's in motion. Okay? Okay. A car on a hill. Okay, we can compare potential and kinetic energy by considering a car up on top of a hill. When a car is at the top of the hill, it has the most potential energy. Okay? If it is sitting still, it has no kinetic energy. Remember we talked about the roller coaster the other day. As it starts up the big hill, it is gaining potential energy. It's got kinetic energy, but it's gaining potential energy as it goes. And once it gets to the very top, when it has that moment of hesitation before it crests that hill, that's when it has the most potential energy. And then when it breaks down and it starts downhill, it starts losing potential energy and it's gaining kinetic energy. Okay, so it just moves back and forth basically. Okay. The potential energy of the position of the car at the hill, on top of the hill, is getting converted to kinetic energy. Again, same way as the roller coaster. Okay. Gravitational potential energy. If you remember the cartoon we watched with the Roadrunner and Coyote.
Oh, yeah.
When the coyote runs off the cliff and he hangs there in the air for a moment or two, that's gravitational potential energy. Okay, he's just hanging there, getting ready to fall. So that he has the potential of falling And of course, when he does, that is converted into kinetic energy. But it's based on his mass, how much he weighs, and the height that he is falling. That's how you would calculate how much energy he generates there. Yes, great.
Are we going to watch any videos today?
You're going to watch part of one, possibly. It's not a real good one, just to be honest with you. One type of potential energy comes from Earth's gravity. This is called a gravitational potential energy, or GPE. Okay? Gravitational potential energy is the energy stored in an object based on its height, how high up it is, and its mass. Okay, how much mass does it have? Weight. Okay? To calculate the gravitational potential energy, we use the following equation, and you're going to use this in a little bit. Okay? GPE equals mass times gravity times height. Okay? Mass times gravity times height. Now, gravity, as I'm sure all of you remember from astronomy, is always 9.8. So if you have to plug in gravity, you plug in 9.8. Okay? And that is where it talks about in the next paragraph, where G is the standard acceleration of gravity, which equals 9.8 meters per second square. The height is determined based on the height of the object. It could potentially fall. And the height may be the distance above the ground, or perhaps the lab table where you're working, or whatever, okay? But again, you can take that formula, GPE equals M times G times H, and you can't solve that unless someone gives you numbers to plug in, okay? You can't actually multiply M times G times H if you don't have something there to plug in, okay? So it gives you an example here. What is the potential energy of a 2-kilogram rock sitting at the top of a 10-meter cliff? So you plug those numbers in. And then you wonder why Robin Hood calls you. Okay? So you have to plug it in. The mass is the 2 kilograms. The
Is that your phone?
no. Turn that completely down there. I apologize. But the mass is the 2 kilograms. And the gravity, again, remember the formula up here. Gravity is 9.8. So you plug in 9.8. Anytime you see a G, you plug in 9.8. Okay? The height, it gives you 10 meters. So you go 2 times 9.8
Which is 19.6.
is 19.6 times 10,
Is
196.
Yeah.
Okay, that's how you got that. Okay, so potential energy and work. The potential energy is equal to the amount of work done to get an object into its position. For example, if you were to lift a book off of the floor and place it on a table, okay, the potential energy of the book on the table will equal the amount of work it took you to pick that thing up off the floor and put it on that shelf or on that table. Okay, and I'm sure you all remember the formula for work. So I'm sure you go home at night and you figure out how much work you are doing at any time using the formulas, right?
Yes.
Yes, of course. Okay. Other types of potential energy. Elastic. Okay, elastic potential energy is stored when material stretched or is compressed. Examples of elastic potential energy includes the springs, rubber bands, slingshots. Think about that slingshot the other day, that big one that they were shooting, the big ball. Think about the fact
it has that elastic potential
it does.
energy.
It does. It's got when you crank it back, it's got elastic potential energy.
You also said as long as you hold it back, the more energy.
Exactly. And if you remember with that first time when they shot it, it hit the block of wood. It didn't destroy the pumpkins. It hit that block of wood down underneath, right? Now, Braxton, somebody walked in. That's all it takes, son. So it hits the, you can just lay that on my desk. Thank you. it hits the block instead of the pumpkins. Okay, and they explained to you what happened was, first of all, it was cold. Second of all, they had cranked it up and left it stretched out for a longer period of time, so it wasn't at full potential. Okay, it didn't have the elastic energy that it should have had. It got weak. It was stretched out. It was tired, I believe was the word that they used. But then when they poured it back and fired it pretty quickly, of course it hits the pumpkins. Okay? All right. Electrical potential energy is the capacity for doing work based on the object's electrical charge. Nuclear potential energy is particles inside of an atom. An atom all by itself is pretty easy to get along with, but if you figure out how to split those things and do a few other things, you can destroy the world. So that's not a good thing. Chemical potential energy is the energy stored up in substances due to their chemical bonds. An example of this is energy stored in gasoline for a car. Okay. Some interesting facts about potential energy, or at least some facts. I don't know how interesting you find them. Scottish scientist William Rankine first coined the term potential energy in the 19th century. So someday you might coin some phrase, and two centuries later or better, you will have your name in a printout in 6th grade. Wouldn't that be cool? Okay. Yes, sir.
Isn't it kind of funny how, like, you say 19th century, but that's like the 1800s?
Yeah, it is. The equation for calculating the potential energy is of a spring is potential energy equals 1/2 times K times X squared. Okay, you really don't need to know that. We're not going to worry about that one. And the concept of potential energy goes all the way back to ancient Greeks. Okay, actually Aristotle was discussing that. All right, very good. Thank you very much, and we will see you a little later on.